In this lesson, we are going to learn about applications of thermodynamics in cookware. Aini plans to cook soup. Which pot should she use? An aluminium pot or stainless steel pot? The selection of pots and pans can be a complicated affair. The important factors in choosing cookware are the shape of the cooking surface and handles, materials used in its manufacturing, the intended purpose of the utensil's design, and its flexibility of use in the kitchen. The purpose of cookware is to transfer energy to ingredients. In a gas stove, the gas comes out at regular intervals and forms a ring of individual flames. Because the heat is not applied evenly, the cook must be aware of this and either compensate with better cooking techniques or good cookware. High-quality cookware should not only be durable, but is effective in transferring energy to the ingredients. There are several factors that affect this capability. The two most important factors are thermal conductivity and heat capacity. Thermal conductivity of a material is how readily that material absorbs and transmits or releases energy. Drag the Bunsen burner and click on it. Observe the animation of molecules. When the burner is turned on, the area directly under the burner gets hot immediately, while the rest of the sheet slowly heats up. The burner transfers heat quickly only to the region of sheet directly over it. The rest of the pan heats up from the conduction of the heat from that spot. When the outer edges of the sheet have reached high temperature, the spot directly over the burner would be extremely hot. Materials with high thermal conductivity fulfill our needs because it transfers heat quickly, resulting in fast response to thermal changes and even distribution of the internal kinetic energy. The common materials used in cookware are copper, aluminium, cast iron, carbon steel, and stainless steel. Of all these, copper has the highest thermal conductivity. What happens when heat is supplied to a material? Drag the Bunsen burner to any position and click Start. Observe the animation of particles. The molecular composition of some materials is such that as they absorb energy, much of it gets converted into potential energy, and only a small amount increases the molecular kinetic energy. What this means is that cookware made of materials with high heat capacity will take longer to heat up, but will also have a significant amount of energy stored up when it is hot. When materials with high heat capacity lose heat energy, their temperatures decrease slowly as compared to materials with low heat capacity. Since heat capacity depends on the mass of the material, to compare cookware of different materials, density must be considered. From the table, if you supply specific heat with density, you'll find that the heat capacity per unit volume of steel, cast iron and copper are about 1.5 times that of aluminium. What can you conclude from the calculation? Compare the heat capacities of stainless steel and aluminium. To achieve the same heat capacity in an aluminium pan as in a stainless steel pan, the aluminium pan needs to be 1.5 times. Click on the properties to know more about aluminium. Click on the properties to know more about stainless steel. Understanding the materials used is a good first step in understanding how cookware works and what factors may be important to your cooking style.